Good afternoon, everyone. My name is Dale Brosius, and welcome to Innovation Insights for July 2023. Hope everybody's having a good summer. We've had a good one, including a very vibrant members meeting last month, and we're going to take advantage of some of that vibrancy from that members meeting to highlight a few of the presentations that were there, but give those presenters extra time today to delve a little deeper into what they offered. Just a quick overview again. Remember about IACMI, we were centered around the themes of convene, connect, and catalyze, bring people together, hook them up, and then make great things happen. We do that through a number of things, including the recent co-funding that we received from the Department of Energy. More on that to come in the next month or so in terms of how to access some of that funding and co-funding and work with us to continue to propel the composites industry forward. This is, again, it's a monthly webinar series. It happens most months except for the month we have our members meeting, and we had or if there's a significant number of conferences going on, and we want to steer clear of those, knowing people will connect at those as well. But all of our previous webinars are on the IACMI website going back a couple of years, so you can tune in there and watch anything that's been presented up to date. So we've got a great lineup. I'm not going to spend a lot of time today tying up their presenters' time. So we've got three great presenters. Again, all three of these presented briefly. Again, I say briefly, even as short as 5 minutes at the members meeting, but they've got a lot more to say and a lot of interesting technologies that I think will be of great interest to the community as a whole. So with that being said, I will introduce John Dispennette. John is the president of Omnia Products in North Carolina. As soon as I can unshare, I will. John, it's all yours.
All right, great. Thanks for the introduction, Dale.
We'll just go into slideshow mode and we'll be good to go.
All right, so thanks again for the introduction.
Yeah, we're good now.
All right.
Perfect.
So
today, hang on just a second. Just for folks online, if you've got any questions during this, feel free to put them in the chat, or there is a Q&A box that you can put questions in, and we will get to those in the allotted time that we have. So go ahead, John. Thank you.
All right, great. Thanks. So today I'd like to give you an introduction to Omnia Products, what our services are. I want to focus a little bit on the sustainability aspect and how we provide value to your supply chain with various projects that we are involved in. And I'd like to use a particular project that we've been doing with Cabot Corporation to highlight those capabilities, as well as some interesting products that Cabot is offering as well. And then we'll summarize and close. Okay, so to begin with, Omnia Products, our focus is we are a services provider focusing on fiber sizings and precision chopping of various fibers. We work with standard sizings or specialty sizings, but mainly water-based sizings. We work with companies ranging from small development to large corporations. We actually serve as an outsource for a few fiber manufacturers where we provide specialty sizings that are outside of the scope of their standard product offering, and they use us as an outsource for that. We also chop fibers. We precision chop ultra short fibers, anything less than 3 millimeters down to say 0.5 millimeters. And we also chop fibers from small to large length fibers for various applications such as compounding or wet laid processing or even longer for karting applications. We also provide some products. There's a few standard items that we offer, and all these standard items are based on sustainably sourced materials. The bulk of what we are providing are carbon based materials, where we have applied thermoplastic sizing to that for compounding. We also provide chopped fibers for wet laid and other processes which are sourced from sustainably sourced suppliers. And we also have products that we make ourselves with some of the upcycled materials, and that's a tire sealant. I won't really go into that today, but we do utilize some of the fibers for our own internal products as well. So this is how we fit within the supply chain. We work with both customers and suppliers. We look at the customer where we are reclaiming materials. A lot of times we'll either just chop their end of run material and provide it back to them so that they can have a source of chopped fiber, or we may be working with other partners such as thermoplastic compounders or BMC or even wet laid companies where we chop fiber or oversized fiber and chop, and then provide that to the third party, which then processes the material, then provides it back to the customer. Today's talk, we'll actually be focusing on that scenario, but we also work with companies that act as suppliers, where they are just providing us material, and maybe we are finding other opportunities through new products where we're just repurposing the material as well. So we're interested in working with both types of scenarios, but probably the one that we do the most work with is the customer base, where we're repurposing or reclaiming material back for their particular use. Okay, so this leads us to today's example. We work with Cabot Corporation. They have a very interesting product. It's a CNS or carbon nanostructure material, which they have trademarked as Athlos. And here in the picture on the right, you can see in the red box would be the CNS material that has actually been grown on a substrate, which is the glass fiber. So glass fiber is highlighted in the green block, in the green box. If you zoom in closer, you can see actually the branching structure of the CNS material in the lower image. So very interesting material. The material, the advantages is it has a high level of percolation compared to other carbon additives. So it provides a continuous structure with less material. And this allows as indicated in the chart below, an improved electrical performance with lower loading. So you can see the CNS in the blue on the left, less than 1% has an equivalent ESD rating to that of other additives, such as a carbon black material. So very, very interesting material. So how that is produced is where we get involved in this project. So on the left, you have a glass fiber with a catalyst, which feeds into a furnace. And inside this furnace is where the CNS substrates are grown on the fiber. As it exits the furnace, they are actually harvesting this grown CNS material off of the glass fiber through a series of air knives. And so that is where they're recovering the material for their Athlos product. So then what's left as the fiber winds back up is the glass substrate. And you can see the picture of this glass substrate to the right. So it's, this is a glass fiber and you can see how dark it is. So there is a percentage of CNS material that is still left on the fiber toe. So, there should be some good value in this product, and we have been working with Cabot to figure out how can we reclaim this product and convert it into a usable format. So during this development activity, we have been working with this this DOFA material, which is a series of several toes that are combined into one. So it creates a very large multi-toe DOF of fiber. And for this case, we have been focusing on how to convert this into a feedable pellet of thermoplastic size material for compounding applications. And the result is the picture on the right. So during this development activity, Omnia has had the responsibility of developing the process, figuring out an optimized way to handle this material and process it. Cabot has been involved or selecting the chemistry and also in the evaluation of the resulting performance. In a lot of cases, when we're working with customers, they may just ask us to do both, where we're selecting the chemistry as well as developing the process. But in this case, Cabot has taken the lead in the chemistry. So, we're open to working in a variety of ways in various projects such as this. And so this is the result. So as we have worked through developing this process and product with Cabot, they have done some benchmark testing and utilizing a 30% glass-filled nylon material as the baseline benchmark material. They have compared this to both the what we're calling the RCGF, or recovered carbon infused glass fiber, which is the acronym for that. Comparing that with the benchmark glass fiber filled, and also Cabot's standard product, which is the Athlos CNS material. So presented here are some of the mechanical properties. You see that there's very little difference in the mechanical properties associated with either the recovered material, the benchmark material, or the glass filled with the CNS product. But then interesting enough, when you look at the electrical properties, you can see that with a 30% glass filled RCGF material, you're approaching very similar properties as with a benchmark glass filled material with the CNS product. So the amount of CNS that is still left on the glass was expected to be something in the range of 0.3 to 0.6% of CNS still left on the glass. So looking at the data, it does coincide very similarly to what a virgin product with CNS resulted in. So the project has been very successful from that standpoint of view in developing a product and process from the reclaimed material. So if there are any questions about our services or the products that I referenced, I would be your point of contact for that. And then we also made reference to both a the Athlos CNS product and also the reclaimed carbon glass fiber as well. And here's your contact information for Cabot if you have any interest in those products as well. And that should wrap it up, Dale.
Thanks, John. Give folks who are online a chance if they want to enter a question or two in the chat or in the Q&A. But so I'm struck by something there. So what are the options for length? I mean, are they the same as any other fiber that you can chop it to and form it into these packages for use in feeding into compounding lines?
Sure. Yeah, we've provided to Cabot both 3 millimeter and 6 millimeter specifically for compounding applications.
Mm-hmm.
You know, we would not be limited, you know, if there were other possible processing needs, we could certainly offer that in a longer cut length than that as well.
Yeah, because it clearly seems as if this was otherwise a waste product. I mean, it was just a carrier for the main process to be able to scrape off these nanostructures that they would sell in bulk, or you know, to somebody to percolate or whatever into other materials. Any reason why you couldn't take this as doffed and put it through an SMC line without, you know, and chop it in line on an SMC line?
I believe that should be possible. Yeah, I think that there could certainly be an opportunity for that as well. It is because of the large toe and how we've been handling it, is, you know, a bit fluffy because it would not have any size. It would act more like an unsized fiber.
Oh, okay.
Coming off the DOF, you know, after their processing of removing the CNS material. So it might be a little problematic, but haven't attempted that.
So okay, but if you were to size it, it might take away from its electrical properties. Is that possible?
No, I don't think that the sizing should influence.
It wouldn't coat it in a way that would be enough to coat it enough to stop that.
No, I don't believe so. We're doing relatively low sizings, you know, similar to you know, what you would typically do for compounding applications. We could certainly even provide a lower sized material for other potential applications, I would imagine as well.
Okay, so I have a question that's come in actually from one of our other panelists here, but can a higher loading of the CNS be left on the toe prior to chopping? You know, in other words, I mean, I guess, you know, put it on the toe and don't scrape it, or only scrape part of it. Could you adjust the amount that's left on there as a residual, all the way up to having it all on there?
Yes. Actually, when this product was first developed, that was the way that it was applied. We actually sized the material with the full complement of the CNS material still in the glass fiber, and that's the way it was utilized.
Mm-hmm.
There is some downside in that you do have a lot of extra material, you know, being the glass.
Mm-hmm.
So you can't get as much loading probably as you would like due to the glass. But, you know, it depends on what sort of electrical properties you're looking for. But yes, the answer is it could be done, because it was that was the approach initially. I believe Cabot probably discovered a more effective way of utilizing that CNS material by extracting it off of the base material.
Yeah, I guess if you didn't necessarily want the reinforcement of the glass, you wouldn't do that, but it seems like you could take some of this glass, you know, and mix it with other non-sized or non-coated glasses, and you know, if you were trying to make a true structural material.
Right.
Yeah, kind of it's kind of unique there. There are a couple of other questions in the chat, and what I'd like you to do is go in and into the chat, make sure you're answering everyone, and answer those questions during the next presentation.
Sure.
If you can.
I'd be
Okay,
happy.
so that we can move on. All right, thanks, John. Great stuff. You can stop sharing, and we'll move on to our next presenter, is Henry Sodano. He's the president and CEO of Trimer Technologies. Henry, can you?
Yeah, can you see my screen?
It's coming up. Yep, looks good. You're all set to go.
All right, great. Yeah, I'll jump back here. Thanks, Dale. I appreciate the invitation to present this work. So what I'm going to talk about today is a new resin system that Trimer Technologies is commercializing. I'm going to share a lot of data, and I have a number of slides, so I'm going to go a little quick here, but really going to try to convey some of the exciting benefits that we can offer with this new resin system. So kind of what is the baseline? Why is this offering a good value proposition to our customers? What we have is a very low cost system. It is an automotive kind of pricing system, but we can achieve aerospace grade properties. We can generate glass transition temperatures better than polyimides. We have a low infusion viscosity, so we can just very rapidly shoot parts. That's either through HPRTM, RTM, VARDM. We have resin systems that are suitable for bath pultrusion as well as injection box pultrusion, offering some of the fastest line speeds that are available as well. Also, the polymer is innately fire resistant, and so we can generate structures out of some complicated processes for fire resistant materials such as pultrusion that have quite easily met the FAR 25853 standards for aircraft interiors or mass transit, Class A E84 rating. So really some very exciting materials. All of those properties are inherent to the material. So, aerospace properties from mechanical strength, stiffness, toughness, fire resistance of phenolics are better, very fast cure. So we can actually, I'll show you, exceed the state-of-the-art epoxies and snap cure systems and exceed what vinyl esters, polyesters can do. And then, we can also process parts quickly with the low viscosity as well as autoclave or out of autoclave process. So just to show you a little bit of properties here, the glass transition temperature that's listed on this slide is the add-of-dye temperature. That would be attained through as little as a 23-second cure is kind of the fastest process that we've run. But you can attain very high glass resistant temperatures with fairly modest cool temperatures. Across the screen there are a number of 2 epoxies and 2 vinyl esters. One thing you might note is the vinyl ester viscosity is totally dependent on styrene content. Our resin is styrene free. So if you're thinking about issues going in the future, future components that you may want to eliminate styrene, eliminate VOCs, our resin system is something that's going to enable that. So if you're using brominated vinyl esters, you can move away from those types of systems. The mechanical properties you see are quite significantly better than competing automotive resin systems. These are kind of industrial / automotive materials. And if I jump forward, this is comparing it against other resin systems that are in the aerospace industry. So kind of the primary structure that or primary resin you would typically compare aerospace materials to is this Hexel 8553. It's a polyether sulfone toughened epoxy. It has about 20 to 25% polyether sulfone, so highly thermoplastic character, but a very tough system, and we can compete with that material very well. Glass resistant temperature that I'm showing again is out of the tool at post cures. We can achieve glass resistant temperatures up to 400 Celsius. So we can actually exceed the polyimides that I'm showing on this slide, and we greatly exceed BMIs. So really kind of a unique system. Being a system that is fairly high modulus, we were showing a 4 GPa modulus there. It does have considerable elasticity. So on the plot on the left, we have the typical tensile neat resin specimen is showing over 100 MPa tensile strength. That's fairly common. Modulus on that particular part. It's 3.7 GPa, so quite good. And a 4% strain to failure for an aerospace grade resin system is very good. So a lot of times I might hear, well, you don't have that 7 or 9% strain to failure we see in some of these automotive systems or infrastructure systems, and that's really not something that you want. Those, a strain to failure in a carbon fiber is 1.7%, a little higher in glass, but really you're not gaining anything from having something that compliant. And really what it is just you're not generating the cross-link density quickly enough like we can do. Our chemical stability is excellent. We can't even do an acid digestion with nitric acid in this system. We have to switch to a piranha solution to do that. So really no change in the mechanical properties with any kind of solvent that we've seen. Stating that kind of compliance that this is a high modulus system. On the left, I have a compression specimen at 9% strain prior to failure. On the right, we have a flexural specimen at 5% strain to failure, or 5% strain. At that point, the ASTM is actually invalid. So you can get very good compliance out of these materials and maintain that high strength and stiffness. This plot is just showing some of the thermal stability that I mentioned. So glass transition temperatures can be extremely high. These can be done with a fairly simple post here. And we do have a new supersonic wind tunnel blade that's going to be utilizing our resin system. That's a 450F continuous use temperature and a 20-year fatigue life application. So really we can do some very good thermal performance as well. And this could be just a standard system. And also we do have some more aerospace kind of level performance that perform a little better out of the die than you might see in some of our infrastructure materials. Just to kind of show you this high rate manufacturing, really one of the novel features of our material. Our slowest resin system cures in about 20 minutes, and that's the slowest. Our fastest resin systems cure much quicker. So this is just to show a liquid compression molding application. It's a steel tool and a closed die. What we have here is these plots are showing ion viscosity velocity. It's essentially dielectric loss. It's monitoring the ion mobility in the polymer. So as the polymer is being cured, let me just show you what's happening here. This first 7 seconds is the press closing and vacuuming applied to the compression tool. As the resin is coming in contact with the center and the temperature of the resin is increasing, you get a viscosity drop once you get better ion mobility. It reaches a peak, at which point we're starting to cure the polymer, lock up the material, remove ion flow, and then it'll say drop down, and when it reaches baseline again, you're fully cured. And so in this case, you have at 30 seconds, given this 7-second press closure, we've cured that polymer in 23 seconds. So extremely fast cure rate. This is a 3.5 millimeter thick fiberglass part with an unheated resin. So if you have a preheated resin and you're doing RTM or HPRTM, it can go faster. Really very, very, very quick material. So what we did is we've done some thicker components. This is showing a 10 millimeter thick composite. It was cured in about 60 seconds, and this is a little thicker there, and it's shown it's curing in about 90 seconds. So really very fast, potentially too fast for some applications. And so what we did is we've developed the technology to latenize our resin to provide tailored cure rate. So that's shown in this plot on the right. So what we have is 3 different resin systems here with different sets of latency. And what you see is this upslope is the same in all of these. So this is the press closure, viscosity drop. It's a little higher in these more latent systems because it's allowed to, its temperature is allowed to progress further. But we have a plateau in these materials. And that plateau is where the material sits at a very low viscosity before it snap cures. And we can dial that in very accurately. So if there's a particular tool that has a long runner, a large part that we need to say, I need 40 seconds of infusion time. All right, well, we have a resin system that'll do that and it'll cure by 60 seconds. So we can really dial in kind of tailored performance for particular tooling or particular applications, manufacturing methods. What you see in all of the downslopes in all of these is that they're the same. So this material is snap curing in the same rate. And what we do is we just dial in that low viscosity region. How long does it need to stay at a low viscosity before it snap cures? And so that's kind of a really unique aspect of our material where we can tailor a solution to a particular part. This particular resin It exceeded the DOE's 2050 goal this was about 3 years ago, to achieve a cycle time of 30 seconds. And the DOE's 2050 goal was less than 1 minute. I believe they've since, this program was funded by the DOE. I believe they've since revised that to kind of account for our system. So really kind of unique in its cure rate. This is showing a thicker part. So this is the dielectric cure monitor from a 28 millimeter leaf spring. This is actually the production part on the F-150. So this is a part manufactured right now by Rossini using a Westlake epoxy. That part takes 13 minutes to cure. And I'll show you, if you look at the time scale on the x-axis here, you'll see we're significantly faster. The orange line here is the derivative of the ion viscosity velocity, which is shown in blue. And so there's a lot of lines here, but we have a 60-second vacuum and press closure. Resin infusion starts. We jump up in our impedance here. This drops down as we complete the injection. So this is about a 23-second injection for this part. It sits with some latency. We dialed that into the material so that we could ensure that we filled the full part. And then it snap cures. And then in 90 seconds, we're fully cured. And you can see that the derivative has gone back to 0 here. So the derivative's on the right-hand side. And so that's showing that we're curing about 90 seconds. It's 8 times faster than the current state-of-the-art epoxy being used for this part. So really, we can do thick parts and we can do thin parts very quickly. Kind of a game changer for high-rate composite manufacturing. We have also demonstrated we can make very long working life resins. So it doesn't have to be these fast components. If you're looking more at large-scale aerospace infrastructure-like parts, we can actually dial in that cure to be extremely latent. So in this case, this is something that was interested for HiCam. It's a program to look at infusion of large-scale aerospace parts. The challenge that was posed to us is, can you manufacture a part with heated tooling at say 80 degrees C or 85 degrees C, sorry, allow it to infuse over an hour and then snap cure following that. And so you can actually use hot tooling rather than heating and cooling your tooling. So, you know, if you think about a wind turbine blade, that mold, a very large mold, is heated and cooled before the part's removed. This concept is, can we go to more of an automotive concept where you have a hot tool, it's never heated, or it's never cooled, sorry, and you just continually replace parts in it. And so that's just demonstrating we have about an hour, slightly less, but very close to an hour before we snap cure. And then about a few minutes later, it's fully cured and that part's ready to be demolded. So really, we can do some very exciting things in large scale manufacturing components as well. One of our biggest application spaces right now is pultrusion. If you're familiar with pultrusion of fire-resistant composites, you're typically looking at brominated vinyl esters. These are being outlawed in the EU at the end of the year. Or you're thinking about phenolics. Phenolics have a poor toxicity profile. They also have very high void content due to condensation reaction and poor mechanical properties as well. We're able to run very quick. We've demonstrated up to 120 inches per minute in certain profiles, but we can generate all of those mechanical properties and the fire resistance that's required for these parts from tooling that's in a high rate pultrusion. I think the fastest you can typically pultrude, and my kind of what I've come to understand, is about 18 inches a minute for a phenolic, maybe a little less in many cases. And we're able to greatly exceed that while providing equal or better fire performance and significantly better mechanical performance. Really, that's a huge application space for us is fire resistant composite structures. I'm going to go through this a little quick here, but show you some data on fire resistance. This is not an ASTM standard. This is just a neat polymer being subjected to a blowtorch. It'll exhibit some small amount of flame, but no sagging, no flame spread, and it self-extinguishes very quickly. You do the same kind of test on a composite. This immediately extinguishes itself. This is a 3 millimeter thick panel. Didn't have any darkening or anything on the backside. If you look at more ASTM level testing, on the right, this is a 50 kilowatt per meter squared cone calorimetry test. It's an ASTM 1354 test. These values, this is with fiberglass, these values are extremely low. The green line is the average. And these are about a little over a third of what would be required for a Navy submarine. There's currently no material that'll meet that spec. So extremely good fire performance. And these are some vertical flame spreads showing essentially no flame spread, especially in the carbon. If you look at OSU heat release testing, this is a test for aircraft interior, the mass transit. The requirement is 65 kilowatt per meter squared, and we're testing about 28. For the fire, the standard's about 200, or it is 200 in the corner there. And the average we're measuring is under 5. So extremely low smoke generation. And we can show that through ASTM testing as well. This is the 662. If you look down at this B, we're about 0 across the board, even in flaming mode. This easily exceeds the fire resistance for those standards. We've recently, with IACMI funding through the programs that have been supported from the new consortium, we've demonstrated for Rinco composites that we have a Class A EA4 rating with no intumescence. So we can do that with just neat resin itself. Our flame spread in 15 and our smoke index is 250. We actually had lower smoke generation from our neat resin than with an intumescence, and so we can really just use our system and reduce cost that way. S&P 800 is a smoke toxicity test. There's no smoke toxicity issues here. We're an unhalogenated system, and no styrene content, nothing like that. Our VOCs are very low, so we easily meet a smoke toxicity requirement. And this, I'm just showing a kind of application to show you how fire resistant the material is. This is neat resin. I get a lot of questions: can it be pigmented? This is pigmented orange, so that it meets what's required for a buck bar in a lithium-ion battery. So what we're showing is overmolded copper conductors that would be used for EV batteries, and this would be the insulated material. I have a video here. Turn this pointer off. There we go. I'm going to accelerate this. I think I can. Yeah. So hopefully the volume isn't too loud on that for everybody. This is a blowtorch that's being applied to this. It goes for 5 minutes, and I will just pull this along. It's basically inert. If you look at the flame on this, is a very intense. It's a very intense flame, and I will not let this go. So what's happening here is it's just, again, this is about 4 minutes and nothing is happening. This is neat resin. There's no reinforcement, so it does fissure because it does have some pyrolysis and volume change. And I'm going to stop it about here, and I will spin this part around, and you'll see it immediately flamed out. There's no residual. And on the back side of this, you see that it's not even discolored. So that's the thermal stability of the material, really high performance. And then the right image and the static images on the back, that's showing that even in one of the fissures, this is still an insulating material. So if we did have a fire, we shouldn't have a discharge event. Composite properties, I won't really talk too much about. You can look at those, but this is being compared to a Crestapol pultrusion resin system that's used on the current Corvette. And I'll point out a few things. That's a crash resistant part. If you look at our 0 degree compressive strength, we're nearly doubling it. If you look at our 90 degree tensile strength, we're nearly doubling it. That's a very resin dominated property. If you look at our 90 degree compressive strength, we're nearly doubling it. We're nearly tripling the 90 degree compressive modulus. And all of our other strengths are extremely good. And this mode 1 fracture toughness that's listed here, this is double what's achieved by an 8552 composite, pre-preg composite for aerospace. So we do have a very tough material system, and mode 2 is also very good. This is actually mode 2, not mode 1. So I don't want to take too much more time, but Trimer is excited to commercialize this resin system. If there's anybody that is looking for new systems that might achieve fire resistance or just strength, it doesn't really require fire. It's just kind of an added benefit. But what we're really trying to do is revolutionize the aerospace market. Our materials are generally significantly less expensive than any other aerospace resin. So if you're looking for a value proposition, it's quite easy for us to make. But we can do additive autoclave processing as well. Infusion of large parts is quite easy with our tailored cure rates, or gel times. And we're really trying to seek to disrupt the material supply industry by producing faster automotive resins at similar pricing, but with fire resistance, strength of aerospace, all of these great properties. And so please reach out to me if you have any questions, or if you have any interest in pursuing collaboration with our resin. We're glad to work with you.
Okay, we got most 1 minute for if you can take on a question. And and I think this is, when you talk about how quickly, I know you've got this, the question may have come up before you talked about having the extended gel time, but but with the fast curing resin, fast curing times is a concern for voids or air bubbles. And I think you're an addition reaction, not a condensation reaction, right? So
Correct.
Right, so you probably you're not producing any water or other off gases, but is there still a concern for voids or air bubbles?
No, we've seen pretty good. So out of autoclave or pultrusion, we see really nice densities. Void content and pultrusion, it really depends on the process you're running and kind of how you're laid out. But in a well-designed process, will be less than 1% void content and pultrusion. And probably similar in a closed tooling application, we should be close to 0. And then open out of autoclave is a little tougher process. So I don't have an exact number there, but generally we're producing good parts. The 84 panels that were manufactured were all out of autoclave process.
Okay, all right. So kind of runs a little short on time here. There's another question in here in to you. I think I'm not sure it went to everybody. So if you'll repeat the question, if you go in and answer the question online, that'd be great. Henry, it has to do with tensile strength on one of your slides, and I think that may have been a composite tensile strength, not a not a knee resin of 1 GPa. So
on a couple slides back,
yeah,
right here, yeah, that's neat resin. That's with fiberglass, non-crimp fiberglass.
Yep, that was reinforced, not neat. So okay, all right. So again, if folks still have questions for Henry, they can continue to put them into the chat, and he'll monitor that and respond to any of those. Okay, thank you very much, and we'll move on to our third presenter of the day. Seeing lots of crossover stuff here, but that's Tom Drye from Orion Performance Compounds. Tom is the Chief Operating Officer and a founding member of this new fledgling, well, not fledgling, I think they're up and running and ready to ship compounded thermoplastic resins. So Tom, we'll let you take it away.
Yes. Can you see it?
Yes.
Okay, great. Thank you for the invite. Yes, so Tom Drye with Orion Performance Compounds. As Dale said, we're a new custom compounder entering the market. And in fact, we just had our first line come on fully commissioned last month. And we have our next couple lines will be commissioned fully later this month. So with that said, so one of the things when I was asked to present, I was thinking, what angle should I take in talking about us as a custom compounder? And one thing I noticed, well, I've been in this business for 40 plus years, and you kind of get into a certain mindset that, hey, everybody knows what a custom compounder does. But what I found starting this new company, this new custom compounder, is that, hey, you know what? Everybody doesn't really know what a custom compounder does. They have a general feel for it. But some of the questions I'm asked often are, hey, what will Orion Performance Compounds focus on? What's your specialty? What are you guys commodity? Are you guys cost driven? And the answer to this is simply, we're a true custom compounder. And what that means is, we will come in and look at the application, the requirements, and we'll make a product that meets your requirements. So that doesn't mean we have a certain off-the-shelf type product line. We don't have a quote unquote line card, but we have is a process, a business that's dedicated to making a specific compound for a specific application. So I kind of turned this question back a little bit on people asking me this in a very kind way, is in a more introspective point of view is, when you're looking for a compounder, how do you decide on which compounder you want to go with? There's many compounders out there. Some are custom, some are more commodity, etc. And so when we're looking at it, are you looking for a commodity provider or a specialty type thermoplastic compounder. Are you looking for full service or just the basics? Give me material. I don't need any technical service or R&D expertise, et cetera. Or are you a prime or low cost type of customer application that, that's what you're looking for? And then you get into the old quandary, the common, project triangle. You can have, quality, cost, and speed or time. You can pick any two. Well, we try and, focus on all three of them, obviously, but you got to kind of pick and choose what is your strength going to be. So I want to talk about that in the first part of my presentation. On the second half, at the end, I'll talk about exactly what we do to kind of bring some people up to speed on, the kind of things that we can offer, our heritage and type of products. So when you're looking at the company, when you start a new company, such as we did, what do you build your company around? And our chosen driver of those three parts of the triangle is really quality. We're looking to make first quality products and meet the application needs and not over or under engineer it. So when we're driven by quality, then okay, what remains are the cost and the speed components, and we can manage the cost, through our expertise and our value engineering expertise, and the speed element. That's kind of dictated by the equipment itself, and we think we've put in the right equipment for the type of market we're looking to pursue, and the experience level of our staff is really the key to reducing speed and getting products out the door quickly. And we do have some rapid serve type options if speed is really a crunch, and we want to maintain all the different aspects of that triangle. So when choosing a reliable provider, some things you should be asking yourself, and we'll ask you as well, when you're trying to fairly choose that compounder, is what is the product breadth? What do we offer and we offer from propylene up to PEEK and polyamides. So we have a very broad resin family, but as you'll see later in our presentation, the amount of number of different additives and reinforcements that we can put into it are really where the thousands of combinations come into effect. So when talking to a compounder, are they going to force fit you into what they have, or right selling? Materials, are they biased or are they agnostic? I can tell you at Orion, totally agnostic. We're not married to any particular resin or additive or filler. We're looking to make the best product for the application. And is the compounder you're talking to or interviewing, are they just interested in your business for today, or are they looking really for a long-term relationship to have business for years to come? Are they looking just to share shift something, or is it really truly problem solving that they're trying to accomplish with you? Improving performance perhaps, or making it more profitable, product that you're going forward so you can grow your business. So, are they helping you grow your business is basically a question. Technical support, do they have the right technical support, the right experience levels that you need to going forward? And I'll show you some of the things that we have later on in my presentation. Experience, I call it gray matter. I'm not talking about brains. I think everybody is pretty smart that are in the plastics field. But we're really talking about the gray hair effect. People who have the experience, have been around and have seen many things and know exactly how to guide you to the right solutions. You're looking for big or small volume, minimum order quantities. Are you a truckload consumer, or are you a specialty? I need 50 pounds, I need 1,000 pounds kind of thing. And that will be really a great question for the compounder you're talking to and the kind of equipment they have in place. The manufacturing equipment itself, is it new equipment? Is it old equipment that's being held together with duct tape, which unfortunately is true in some cases. I've seen this. Facilities itself, are they conducive to making good product? The lab capabilities, is it really a basic lab or no lab at all, or is it a fully plastics capable type of lab? Accreditations, what do they have as far as accreditations go? And of course, lead times, what's their stated lead times and how often do they meet those lead times? So how a partner engages with you, the customer, as a partner, we look at it as a partnership. A good compounder will help keep you clean. When I say clean, they'll keep your orders aligned, get you on time, and more importantly, they're going to put all these messy, dirty additives into a nice clean pellet that will go through your plant with very little incidents as far as accumulating dirt. Logistics hurdles, let the compounder, they should manage all those. You know, we've seen logistics nightmares over the last couple of years. A good compounder will have the resources to manage those delivery times for all the additives and reinforcements and get them to you on time. Crisis support. Oftentimes plans go awry, and to us as a good compounder, that would be an opportunity to help you. You know, a friend in need is definitely a friend indeed, and you know, it's an opportunity to shine by helping you get out of a tight situation. So that's the right material at the right time. Do they help bring you leads? Are they helping you grow your business? You know, using our extended sales team to help bring opportunities and leads to you as well. Cost control. You know, margins, you know, on a highly expensive material, you can maintain margins on things that are value engineered and lower cost materials. It really depends on, you know, finding again that right material for the right application. So margins can be made at any price level. It's not always about trying to upsell. It should not be about upselling. Is the provider really an honest person doing business? I mean, we read these articles in different plastics magazines about people cheating on either C of A's or changing raw materials and not being upfront about that. Are these really upstanding people that you want to deal with? Because they can get you in trouble. Compliance, you know, ISO, SARA, TSCA, SDSs, OSHA, et cetera, UL are the right regulations being followed and employed. And then there's going to be bad news occasionally, but are they explained fully? And at the same time, are solutions being offered? Can't just be you know, telling you bad news with no solutions. So if you look at IACMI, this is a little pitch for IACMI here. I think many on this call were at the recent IACMI meeting, but really it's the whole is greater than the sum of the parts. Does a compounder bring only himself, or do they bring other resources just like IACMI? And Orion, we are part of IACMI. In fact, the arrow there and that screen is pointing to me down there, if you want to see me way down there in that sea of humanity. But if you look at IACMI, you know, what does IACMI bring to the table? Again, I know a lot of you know this, but you know, the Oak Ridge National Lab, the different academia with UT, UMaine, Purdue, UDRI, Vandy, et cetera, the different states that are involved. There's several integral facilities such as the SURF, NREL, the carbon fiber, the MDF, which is some great facilities. And there's over 200 related, you know, industry partners that are part of IACMI, and resources and knowledge are part of this. So Orion is definitely part of IACMI, and I've been part of IACMI myself for many years, ever since the beginning, actually. So being part of IACMI, which is part of the Department of Energy, it really expands the reach and depth of, in this case, a compounder or any supplier that you might be looking, and they are part of the IACMI organization. So Orion itself, I'm going to kind of get into a little bit, you know, about us specifically, but we are a compounder, a custom compounder. And I say that we're new, but we're 200 years in the making. And when I say that, I mean that our team is very experienced. So we have new building, new equipment, but our team is very experienced. Most people have 20, 30 years, in my case, 40 years of experience. So we know how to make materials, and we've got a great facility. I'll show some pictures here in a moment. But we have the modern, latest generation equipment. We have extensive lab capabilities. These are questions you should be asking of any supplier. And again, our lot sizes are 110 pounds up to truckload quantities, but we even go down to 55 pounds in some cases. It really depends on the application. Customized support. Obviously, we offer that. We're agile. The reach of our distribution team that we use, our salespeople, and we keep an eye on you. The compounder has to keep the customer forefront and exactly what's needed. And again, the IACMI membership benefits and the support team. So in looking at us, there's a picture of our building looking up the hill a little bit, but we are a high-end custom compounder of engineering thermoplastics, and we provide custom solutions to everyday unique challenges. And our center of excellence is located at in Lugoff, South Carolina, just outside of Columbia. Again, as I said, we're a new company with about 200 years in the making. We got a new building, but new buildings don't make the product. It's the people, our experienced staff that makes the product. And we have all new equipment to help support that. We got 50,000 square feet on 26 acres, so a lot of room to expand. We're starting with both twin screws and single screw equipment. And again, we're material agnostic, so we're not going to look to force fit you into anything. We're going to give you the right material for the application. So we're built for expansion. We've done some things to make it easily expandable in the future. And we launched our first line, as I said, back in May, and our next 2 lines will be operational later this month. Not the typical grow as you go approach. We really started off pretty big with a big facility, all new equipment, and a very experienced staff. So this is not a slow start. This is jumping in both feet into the deep end. Here's our facility. Again, our building on the left. The top right, you see our front office area. And the bottom right is our little picture of our production area. You can't see the whole thing, but then the bottom middle is our laboratory. And again, looking at the resin family, so there's crystalline and amorphous materials. So crystalline is characterized by what you see there, the good wear and friction, good chemical resistance, and amorphous characterized with kind of not so good wear and friction, but great chemical, and less chemical, but good shrinkage properties. And I'm going through this rather quickly to fit it in the time slot, but our products go from polyolefins up to peaks and those resin families, all types of reinforcements, additives, and fillers. This is a partial listing, but many different additives that we have to customize the product for the application. Conductive additives, carbon fiber, carbon black, stainless steel, for example, wear and friction additives, as you see, typical PTFE, silicones, aramids, and others. Flame retardants are a big thing for us for our UL product lines, structural component materials, and all types of stabilizers and enhancements. So basically we start, if you don't know what a compounder does, we start with plastic pellets and, from resin suppliers. We put things like carbon fiber, glass fiber, and all types of additives into it, colorants. And we take those, we put in our secret sauce, we pass it through a twin screw extruder. Extruder comes out in die face and strands. We cool it, we pelletize it, and out the door goes highly specialized pellets. So we kind of start with pellets and we end up with highly specialized pellets. If you haven't seen an extruder for thermoplastic, that's what they look like. And there's the strands coming out, entering the cooling bath. I've got a couple minutes left. Here's our trade names, but you can see we kind of block it out, really not as a line card where here is our offerings. Our offerings are really, could be anything. We'll mix and match our additives, but we block them into functionality groups: conductive materials, lubricated materials, engineered or structural compounds, unfilled colors, flame retardants, shielding materials, and then additive manufacturing, and eco-friendly is a product line that we're looking to expand really on this new venture because of the whole circular economy. We're definitely paying attention to that, environmentally friendly type materials. Just a real quick resistivity continuum. So insulative, polymers start off insulative around 10 to the 15th or higher ohms resistance, all the way down to maybe 10 to the 0, 10 to the 1 ohms in a shielding type of compounds. And some of the applications, so here's some of the eco-friendly, something that we've done in the past, the previous company, some PLA with bamboo, again, all environmentally friendly type materials. You get there's so many different choices, and you as the consumer say, how do I choose? I'm really confused. But as the partner compounder, our job is to design, to help you get through that. You design the part and the function, and then we, Orion, will design a material solution for you to remove that headache. So where do all these pellets go? Well, the markets that we pursue are medical, electronics, aerospace, business machine, pretty much every market space we are in, and we'll look to expand upon all these as well. Construction and military, you see some of these applications from the past that we worked on, all types of really neat and interesting things. These happen to be some 3D applications that we did, some very large printed 3D materials. Again, you see some applications that we did: a helicopter blade tool, a boat plug tool, and down the bottom right was a Boeing aircraft tool. Some of these, again, some of the really big 3D materials that we made. If you saw the Vegas Raiders, that torch that's in the Vegas Raider Stadium is stuff that made with our material. And again, our past experience is where we come to light, where we come to shine to help you with a product line or a product that meets your application needs. So to wrap up, so why choose Orion as your material partner? It's our entrepreneurial spirit, our vast experience. Yeah, it's in a new package, in a new building, but it's the experience inside that building is where it counts. Our minimum order quantities, 55 pounds, 110 pounds, up to truckload. Our technical expertise. And again, we sell properties and solutions. We already sell material. We sell properties in the form of pellets. And we're a value-based solution provider. And again, we're resin and additive agnostic. So we're problem solvers, and we have a can-do approach. So again, thank you very much. We welcome the opportunity to be your compounder. And again, we sell properties. Thank you.
Thanks, Tom. And yeah, I did see one question that came in the Q&A, but it was really around me asking if there's an opportunity to get copies of presentations. And so if you are interested in that, please reach out to Kim Hoodin. It's KHOODIN at IACMI.org, and she'll work with the presenters to get you a copy of presentations. Don't forget this whole webinar has been recorded and will be up and posted probably within the week, so that you can go back and look at anything that was there, pause it at that point, screenshot what you need, and get the information you want as well. So Kim's information is in the chat, webinar chat right now. But again, I want to thank all of our speakers. We've hit the end of our time for this month, and we will see you again in August for the next edition. Enjoy your week, everyone.